Welcome back. All right, so today we're starting on page 199 and we have the sections called mole problems, not just in your backyard. So we started talking about the mole last time. And remember, 1 mole, that's just a number, kind of like 1 dozen is 12 of something. 1 mole is 6.02 times 10 to the 23 of something. In this case, we're in chemistry class, so we're probably talking about atoms or molecules or something like that. Okay, we start off this section right away with an example, and I have another video where we worked through it, but I'm probably going to work through it again using a chart that we made and discussed in class. So in this one, we made this little chart. Here it is, like this. And we can use that even when we don't have a full reaction or a full thing. We're just talking about the mass of something. So I'm going to screenshot this and show you how to use it so that it makes sense. Okay. Oh, that was... I don't know where the rest of my text went. Oh, there it goes. Okay. Well, I was trying to zoom in and put it back up there. All right, there we go. All right. Okay, so it says, what is the mass of a single molecule of glucose? And it gives us the formula for glucose, and they tell us that it is C6H12O6. And when you take biology, if you've already taken that or if you take it later, that is an important molecule to remember. And it wants to know what is the mass of a sample of glucose, and it tells us how many molecules it contains. And so you might look at that and think, I'm not even sure where to start. So let's start by talking about the first question. What is the mass of a single molecule? So if I said, what is the mass of a single atom of carbon, I would say 12.01. That's just 1 carbon, right? If I have 6 of those carbons, then I would need to take my 12.01 and multiply by 6, and that would be the mass of 6 carbons. I got this number, 12.01, off the periodic table. It's the atomic mass. I can repeat the same thing with hydrogen. Hydrogen is 1.01 atomic mass unit, and so if I want the mass of 12 of those, I would just say 12 times that number. And then I could repeat that with oxygen. A single oxygen is 16 point, I need to make sure I'm not rounding these wrong because I'm doing these out of my head. 16.00, good. And yeah, got all those right. So if I want 6 of those oxygen, I'm putting a little curl on my O so it doesn't look like a 0, then I would need to multiply 6 times that. Well, this particular molecule is made of 6 carbons and 12 hydrogen and 6 oxygens. And so if I take those numbers, so 72.06 is the first one, and 12.12 is the second one, and 6 times 16, I should probably pull out a calculator, I think that's right, is the last one. And then I add those together, I will get the mass of that. Let me do that real quick and make sure. 12.01 times 6, good, plus 12. 1.01 times 12 plus 6 times 16, and I got 180.18. So that would be, so 180.18. That's the mass of 1 molecule. The reason I'm allowed to do this is because that number on the periodic table tells us the mass. Now that is in AMU because that's what the periodic table gives us. Remember that pink chart at the top of page 199? I'm going off of number 1 on that chart, the mass of a single atom. So a single atom of carbon is 12.01 AMU. A mass of 6 carbon is 72.06 AMU. And the mass of 1 molecule with 6 C's, 12 H's, and 6 O's altogether is 180.18 AMU. All right, and then, oops. And so that answers the first question. The second question is where I pulled my chart out for it. It asks for a mass of a sample of glucose, and it tells us how many molecules it contains. Actually, I don't really need the chart for this, but we're going to use it anyways just to help it make sense. So let's list C6H12O6. So here's our thing. We don't need any of the rest of these because we don't actually have a reaction happening here. We're just working with one element, but we can use the chart while we work with one element. And they tell us how many molecules it contains. They tell us in the book that it has 6.02 times 10 to the 23 molecules of that. Now, my chart doesn't have molecules. It has moles and it has grams. I don't need the equation coefficient because there's no equation. So I'm going to scratch that out too. I don't have molecules. I only have moles or grams on the chart. So I need to change this into something. At the end of the chapter, when we had a review, we learned that different things can convert. So I can go from moles to grams. I can go from moles to moles. I can go from those moles to grams of that mole. I can't go straight from grams to grams. I can't go from molecules or atoms to grams, but I can go from moles to molecules, or atoms if it's a single element. And so that's what I'm wanting to do. How do we go from moles to molecules? We use Avogadro's number. So in this case, they told me this is how many molecules I have. So if I use this information up here, 1 mole is that many molecules. I'm going to write this out, even though after I write it out, you're going to be like, that's so silly, you could have not written that out. So I have molecules down here and moles up here. And I'm going to use that conversion because that's how I get from moles to molecules. 1 mole is 6.02 times 10 to the 23 molecules. You may notice something right here when you start canceling. Molecules cancels out, and guess what? The number right here is the same as the number right here. So if you type that in your calculator, what answer would you get? You would get a 1 because this and this would cancel out. You'd have a 1 here and a 1 here. 1 times 1 divided by 1 is just 1. So how many moles do I have? That's my only unit left. I have 1 mole, so I can put 1 right here. Now, what we're trying to do is we're trying to find how many grams. That's what they asked for, was this number right here. This is our question mark, so we can go ahead and fill it in. We found the moles, and that helped us figure out how many grams. Now, if we want to convert to something that uses the, if we want to go from moles to grams, let's go back to our chart again. From moles to grams, it doesn't matter if you look at the moles and grams that are in the light green or the moles and grams that are in the dark green. That's just to show you that if you have grams of 2 different things, you can reach them by going along this path. Let's just focus on just the grams and moles on just one. Okay, there we go. Well, whatever. It won't let me highlight just these. What we're focusing on is the moles and grams right here, because that's what we're trying to get between. How do we convert? We use something called molar mass. Now, in your book, they're not calling it that yet, but because we've already been through the chapter, we've talked about this. So we're going to call it this from the beginning so that it's consistent throughout the chapter. For molar mass, that's what we call it when we say, how many grams is in 1 mole? And that's what this blue box is down here. If we can fill that out, that can help us convert. Now I'm going to go ahead and erase some of this extra stuff over here so that we have a little bit less mess. I'm going to erase this. And the reason I said you probably would think I was silly for writing this is when they told me how many molecules I have, I could look at that number and say, hey, that's Avogadro's number. That means I have a mole. So I didn't really need to make that. What I do need to do now, though, is I need to fill in the molar mass. Well, one thing we learned back on page 199 is that the number of grams to have a mole of atoms comes from the periodic table. So like carbon, if I have a mole of carbon, it's going to be 12.01 grams. So if I have 1 mole carbon, it's 12.01 grams. If I have 6 moles of carbon, it would be 12.01 times 6 grams. If I have 1 mole of this thing, that means I would have, so let's put, this is one of these. have 6 of 6. Let's pretend I want 2 of these things. I'm going to write it again. Let's pretend I want 3 of these things. I'm going to write it again. How many carbons do I have altogether? At first I had 6 of them, but if I have 3 of them, I now have 18 of them. And so if I have a dozen of these, let's pretend, oh, that was messy, I should have done that better. Let's pretend there's a dozen of these. I just didn't write them all. That means I have 1 dozen C6s, or in other words, I have 12 times 6 C's, right? That's what's happening up here. I have a mole of these. So that means I have a mole of C, 6 of them. I have a mole of H12, or in other words, 12 hydrogen. And then I have a mole of O6, in other words, 6. So I have a mole, or I have 6 moles of carbon, 12 moles of hydrogen, 6 moles of oxygen. I can kind of think of it that way. So when I use the periodic table to find that 1 mole of carbon was this, and 6 moles of carbon is that, that means this number right here, which is 72.06, that's how many grams are in 6 moles. Okay? This number that I came up with right here, just like the pink box that says that the periodic table number tells us 2 things, when I add the numbers and get the atomic mass unit, that is the same as me saying number 2, the number of grams for 1 mole. It applies to the periodic table. 12.01 is the atomic mass of carbon, and 12.01 grams is how many grams are in 1 mole of carbon. Same thing when I added up the way I did to find the mass of 1 molecule. 180.18 is the atomic mass of 1 molecule of glucose, and 180.18 is how many grams are in 1 mole of glucose. So that's the molar mass. That's what we're calling molar mass. So that's grams, and that is for 1 mole. So I can use that now to find how many grams I have. If I know I have 1 mole, this box right here, I don't even have to set up a dimensional analysis or multiplication thing where I line up the fractions and I get the top and the bottom right so I can cancel stuff. I don't even have to do that. This is how many grams are in 1 mole. I have 1 mole and I want to know how many grams I have. It's done for me. The answer, let's see, let's pick a different color. The answer is 180.18 grams. Okay, so that's how you do that one. You don't really need this chart. We'll use this chart a lot more when we start talking about reactions. The important thing from this when you're working on these is, and this was example 7.1, is first you need to understand that the mass of a molecule is just the mass of its individual atoms. If you have something like this, how many carbon atoms make this up? I have 6 carbon atoms. I have 12 hydrogen atoms. I have 6 oxygen atoms. And so if I have the mass of the 6 carbon atoms, that would be the mass of 1 carbon atom times 6. The mass of 12 carbon atoms would be the mass of hydrogen. The mass of 12 hydrogen atoms would be the mass of 1 hydrogen atom times 12. And the mass of 6 oxygen atoms would be the mass of 1 oxygen atom times 6. And when I take all those pieces and add them together, I get the mass of the entire molecule. So that's the first thing you need to understand. We just add the masses. And this is one of the easiest significant figures you'll have for the whole chapter because you don't really have to worry about them. your periodic table is going to give you 2 decimal places. And because this is all adding, even though we're like multiplying by 6 or 12 or 6, we're really just adding that number 6 times or adding that number 12 times. And so significant digits addition rules apply. And all we have to do is keep the number of decimal places we got off the chart. So they all have 2. We'll get 2 decimal places after the decimal. So that one you don't even really have to think about significant figures, which is great. You just find the masses of each piece, multiply it out so you have enough of each thing, and then add all those things together. The second part that was important from this is that we had to understand 2 things. We had to understand what a mole was. We have to understand that a mole is 6.02 times 10 to the 23 of something. In this case, it was that many molecules. And we had to know how to convert between moles and grams. And when we convert between moles and grams, we have to use the molar mass. This thing up here, the mass of the molecule, also will tell us what the molar mass is. The same rules apply that the pink box on page 29 for the periodic table, they also apply to when we're working with molecules. If we find the mass of a molecule in AMU, that number is also the number of grams in 1 mole. Grams in 1 mole. And we use that to convert. We just have to make sure that we put moles and grams in the right place. If we're going from moles to grams, like if we're going this way, and we have moles, we use the molar mass and we put moles on the bottom, and oh, what on earth, and then we put grams on top, and this right here is our molar mass. If we're going the other way and we're going from grams to moles, which we haven't done yet, but let's pretend we are, we would take grams that they give us and we would use the same 2 numbers, but we would put our grams on the bottom and our moles on the top. The same thing right here, but the fraction would be flipped over. So knowing those 2 pieces will help you understand. Okay, so the next thing in this section, they finally give us a name for that. They finally start talking about molar mass. So we're good because we understand that. And then they move on to another example. So example 7.2 tells us how many grams we have of something. A student measures out 15.6 grams of magnesium chloride. It's okay if you don't know how to figure that out. If you need help, we can work through this. We can break it up. In fact, I need to look at the test that I made and break it up, because I think I would say write the chemical formula for magnesium chloride as part 1. And so then you would say, all right, let me go back to my rules from chapter 1. Magnesium is way over there on the left. Chloride is way over here on the right. One's a metal, one's a non-metal. This is ionic. And then you could figure out magnesium was in the +2 area and chloride was in the -1 area. And we just take those numbers and we switch them. So 1 and 2. And when we write it, we don't write the 1. We just write the 2. And so you would be able to have the formula. And then step 2 would tell you how much we have. We have 15.6 grams of this. And they want to know how many moles. Let's do 2 things. 1, let's go look at our chart and figure out how do we get there. And 2, let's go figure out using a different chart how to do that. So we're going to start with this chart. How do I get where I need to go? What do I have? I have grams. So let's pick either the word grams. It doesn't matter which one. And I want to go to moles. What is above the arrow between grams and moles? Molar mass. So that tells me to go from grams to moles. Grams to moles. I need to I need to use molar mass to get there, which means I have two steps to this problem. First, I need to find the molar mass of this, and then I need to use the molar mass to actually make my conversion. So this is a two-part problem. So again, if I decide to remake the test, I probably should separate this into two pieces. I probably should say part 1, so 2a, find the molar mass of MgCl2. And then part 2b, convert 15.6 grams of that to moles of that same thing. And so we can start by using the things we know and get there. All right, so how do we find molar mass? This is kind of the big thing of the whole chapter. And I have on this thing to use molar mass in the more wordy version. I have a little box over here that says molar mass. To find the molar mass, which is how many grams are in 1 mole of that thing, you use the atomic mass number on the periodic table and the subscript times the AMU of each element in the compound, and then add up all the masses. In other words, I have Mg, its subscript is 1, so I'm going to look at Mg on the periodic table. It has 24.31 underneath. I'm going to take 24.31 and multiply it by 1, because that's the subscript that I have over here, the invisible. So Mg, I have 1 of those, and its number is 24.31. Now I'm doing Cl. This one, I have 2 of those, so I'm going to go find its number on the chart. On the periodic table, its atomic mass is 35.45. That means that in 1 mole of magnesium, I have 24.31 grams, and in 1 mole of chlorine, I have 35.45 grams. But I want 2 chlorines, so this is 70.90. I'm just going to copy over this first one. Then I'm going to add them up. So 1, 12. All right, so that number, that would be 95.21. That's grams per mole. In other words, grams in 1 mole. I don't know why I put an S there. The next step wants me to convert. Let's pick a different color. I want to take this number of grams, I'm going to multiply it by something, and I'm going to get moles. To do that, I need to get rid of the grams. I want the grams to go away. So I need grams to be on the bottom down here, and then I can make it go away. And moles on top would give me what's left. I use this molar mass to make that conversion. And that's what this chart right here is saying. This little arrow says use molar mass. This big box tells me how to find the molar mass. So we found the molar mass, now we're going to use it. So this says this many grams per every mole, so 1 mole. And then at this point, I've already scratched out my grams. Moles are all that's left, so I take 15.6 times 1. I'm not actually going to type that because you know in your head what 15.6 times 1 is. It's still 15.6. So I'm not going to do that one. I'm just going to type in 15.6 divided by 95.21. This has a lot of digits. I need to keep 3 of them, so 0.164. Now, if you don't know why I kept that many digits, we'll talk about that later, or you can go back to the significant digits unit. The important thing today is how do we get from grams to moles? We're going to focus on just that today. From grams to moles or moles to grams, we use the molar mass. You may want to repeat that a few times. Let's do it together, like Dora's style. From grams to moles or moles to grams, we use molar mass. Okay? So that's the end of this section. The next section, we're going to start using the mole concept to do more stuff. Okay?